Alright everybody, welcome back. In part one, we made this mold and this mold. This is going to be part two of that video where we're going to actually be casting the replicant gears that we need out of these molds. So let's go ahead and jump right into it. I'm going to be using a high impact resin to cast these gears. The specific resin I'm using is again from hobbysilicone.com. It's the MPK 90 high impact 180-second resin. It comes in two parts. They're mixed 1-to-1 by weight, and that's pretty much 1-to-1 by volume, so that's how we're going to be doing it. This was the right resin for this project because it has just a little bit of flex, about 2%. It casts quite hard, but that little bit of flex in it will stop it from breaking on any sudden impact, like when the motor that turns these gears kicks on and jolts. So that's why we're going with it. To make life easy, we're going to transfer the resin from these big old bottles to little ones just because that's easier to pour with. You'll notice there that when you first mix the components of the resin together, they get cloudy. But as you continue to mix them, they go clear again. No idea why that happens, but don't be surprised if it does to you. So as we're getting a mold ready to use, what you need to do is take a mold release. In this case, it's a PTFE lubricant. Spray the mold down, and then line up our alignment pins, just like that. We'll mix up the resin we need. And just slowly pour in. So it's been about 20 minutes and the casting should be set. What I'll do is pull off that, break the seal around the outside, a great tool to have when you're doing this is an air gun like this. I have mine set to about 60 psi, but I'm not going to depress the trigger all the way when I go to use it like that. I'm just gonna give it little bursts. There you go. There you go. And the mold comes off nice and clean. Here's our casting inside. You'll see quite a bit of flash around the outside, but that's fine. Most of it will just pull right off. There we are. I'm gonna grab our air gun again. And get the piece loose. There we go. Now you'll see that it has quite a bit of flex right now. It actually takes a fair amount of time for it to totally set up hard. So what I've been doing is just setting these on a flat surface where all the details are covered and just allow it to sit until it dries. So I made a sample of this and took it over to the client, and neither one of us is happy with how much flex these have. It's quite low, but it's more than either one of us likes. And these open spaces are not critical to the design of the gear at all. They don't serve any function other than to reduce the amount of plastic that was required in the original. So we're going to cast one with this cavity here filled in. And if that's what we like, we'll make a new mold so that the cavity is part of it, and it still has this little neck right here, which is important. For this first batch, the client agreed this neck is really just a spacer, so I'm just going to 3D print those and stick them on. Alright, so there's the completed casting. It's very hot right now. The resin does heat up. So we now have our two finished castings. We have the original exact duplicate with the open spaces, and then we have our duplicate with the solid top. It's much heavier, much stouter. There's absolutely no flex in it. This is definitely the way we're gonna go. So let's go get the 3D printer fired up and make some little collars to go on here. So what we've done is started out with this gear, which is the piece that needs to be replicated. So the first attempt, just as a rough draft, this was done in a mold without vacuum degassing the mold, and you see all these bubbles. I basically sanded it smooth, but it's still not, it won't mate onto the piece of machinery because it's not perfect. So I'll walk you through what we did here. So this is the vacuum degassed mold. What happened here is this piece was put in here, you know, like that. Vacuum degassed. You see how just immaculate the surface is there. It even picked up the details from the original injection molding machining that show the materials that were used, what kind of plastic. Got a couple of screw ups from trying to vacuum degas the resin. It sets too fast, and it's not really necessary. If you demold these too quickly, you'll see they warp because they get very hot as they're setting. And here are the successful ones that have all the detail we need. This resin is basically perfect for the application for the gear teeth. However, this profile here is very thin, so these have just a little bit of play and flex in them. So what we decided to do was to go with a solid cast. Uses about twice as much resin, but that's not a big deal. Now, unfortunately, with the solid cast in this mold, it does not pick up the detail of this shaft collar here. So what I did was 3D printed some of those shaft collars. These were needed on short notice, so a new mold will be made for future ones, so it'll pick up that shaft collar detail. But for now, these are going to do what they need to do. This shaft collar doesn't actually take any load. It just spaces this on the shaft that it rides on. I still got to clean these up with a little bit of sanding. Had one that delaminated from the bed and just end up printing a booger. These gears actually only rotate at about 2 RPM, and they only take maybe 20 pounds of torque. It's not a lot, so they don't need to be super strong. It's just a specific part that can't be found elsewhere. So what we're doing now is mixing up some, it's a type of 5-minute epoxy. It's Loctite's brand, and I found that it works really well with plastics. And we're just going to dip the collars in that and line them up right where they need to be. Okay, so it's really important to consider the application when you're making something. I wouldn't send them out if they were running at a high RPM and were not perfectly balanced. But in this case, these things turn a couple RPM, maybe 2 or 3. They don't even make a full revolution. So the fact that these collars are not perfectly round on the outside, they're good on the inside. The fact that they may be mounted a couple thou off center, none of that comes into play as a crucial element to these. Don't worry about not having every piece of equipment you might need to do such a detailed mold. This is a very detailed part, and it's basically the worst kind of casting you can make because it has a flat overhang, which is likely to catch air bubbles if you don't have a vacuum chamber or a pressure pot. This is the first mold that I made. It was just the proof of concept sample for the client. You can see I did not have a vacuum chamber set up for this one, and there's all these air bubbles underneath it. The vacuum chamber I consider to be a necessity, but not everybody does. You can pick them up for about $180. I've got one linked in the description, and that's the one I use. You can see that this mold was pretty simple. I made it in a dog food bowl. Doesn't take much to try and get into something new. Let's compare how this one came out to the rest of them though. So you can see here we have our dog food mold that looks like a 13-year-old with acne. This is the gear that came out of it. You can see where I've had to sand off the resin that fills in all those bumps. And it's not perfect, but it's still pretty good. And with a little bit of time with the Dremel, this would work. So if you just need one, it's a pretty good solution. Now we have this mold that we just used. Here's the casting that came out of it. With the vacuum chamber, you see that you end up with, you know, just about a perfect surface finish. You can even see the text in the ejection points where the original piece was pushed out of the injection mold that it was made in. Now here's our third mold. This is exactly the same as this one, except that it has the little channel that's on the original gears, this little piece right here, built on. That just serves as a spacer to keep it on the machine how it mounts. And so that goes together like that, and we're good to go. Hey everyone, thanks for joining me along with this build. It was a little impromptu and kind of outside of my normal range of creations, but these turned out great in my opinion. I hope the client's going to be real happy with them. If you like this and want to see some of my other builds, go ahead and subscribe. Here's a video I think you might like, and here's one YouTube thinks you might like. Thanks.